Hello everyone, my name is Arya Devdar and this is part 2 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so in part 1, we saw the introduction of what exactly is light, we saw what is diffraction, and then we moved on to reflection. We saw the laws and we saw the image formation by a plane mirror, right? Now in this video, we are going to start by differentiating real and virtual images. Okay, so we are going to see a distinguish between real and virtual images. Okay, after that we are going to see the image formation. So we saw the image formation of plane mirror. Now we are going to see the image formation of the spherical mirrors. So basically concave and convex mirror of spherical mirrors and their uses. So what are the uses of the spherical mirror? What is the use of a concave mirror or a convex mirror? Okay, so we are going to see that and their uses. So this is a very important class because an important part because it involves the formation of ray diagrams and stuff. So make sure you pay attention and make sure you understand everything. Okay, so let's start with real and virtual images. So I'll give you a distinguish between, which may come in the board, so it is important and obviously for your knowledge. Okay, so real images. What are exactly real images? See, I briefly explained it in the last class. Basically, when an image is formed by the real light rays, that is, when the light rays converge at a particular point after reflection or refraction, okay, it is known as a real image. So when they actually converge at a real point, okay, they actually converge. That is known as a real image. So the first point will be an image formed when light rays converge, when light rays converge at a particular point after reflection or refraction. At particular point after reflection, we'll write for now. You can write refraction as well. Okay, is known as a real image. Now, what is virtual? Virtual means an image which is formed when the rays appear to meet at a particular point after the reflection. Okay, from the mirror. It is known as a virtual image. So they appear to meet. They do not really meet. They just appear to meet. Okay, so it is not actual. Okay, so an image formed when light rays appear to meet at a particular point. To meet at a point after reflection. So this is virtual image. Okay. Now the second point is that real images, they can be captured on the screen. They can be captured on a screen because the light rays actually meet or they actually intersect, right, in air, right? So they can be captured on a screen. The image can be captured on a screen. However, virtual images, they cannot be captured on a screen because the point at which they meet is imaginary, right? So how can they be captured? So they cannot be captured on a screen. So those are virtual images, imaginary images. Third point is that mostly the images formed are inverted. That means ulta ho jate. Okay, so they get inverted. Mostly inverted. So real and inverted, and in virtual, it is erect. So they remain erect. They remain straight upwards. Okay, so mostly erect. So here in virtual, it is actually always erect, but for real, it may be erect, it may be inverted. So it is, a good idea to write mostly here. Okay, so we don't know for sure. Like if it works in every case. Anyways, the fourth point is that a real image is formed on the same side of the object. So a real image, it is formed on the same side of an object. Same side of object, usually. Okay, same side of object. And here, it is formed behind the mirror. Okay, so you can write it, the virtual image, it is obviously formed behind the mirror. So these are the 4 important points. Other than that, you can give a fifth point, which is an example. So example basically means like which lens or which mirror gives real images and which mirror or lens gives virtual images. So you can give the example. You might understand after a few classes why exactly that happens. So I'll discuss those examples in the upcoming videos. Okay. So for now, just remember these 4 important points, and the fifth point you will be able to write on your own. Okay, now moving on. Now let's see some rules for ray diagrams. Okay, let us see some rules for ray diagrams. So there are 4 total rules. Okay, so let's see each one of them one after the other for both concave and convex mirrors. Okay, so first rule is that if a light ray is reflected parallelly, if it is reflected parallelly, or it is thrown parallelly at the mirror, parallel to the principal axis, okay, then it will reflect back through the focus. It will reflect back through the focus. Okay, so that is the first rule. Similarly, for it's the same thing for convex mirror. So for convex mirror, it appears to have come from the focus. The reflected ray appears to have diverged from the focus. Okay, so it's like this. And you have to trace it back to the focus. Understood? That is the first one. When a ray is thrown parallelly to the principal axis, it passes through the focus, or it appears to pass through the focus. Simple? Okay. Now the second rule says it's the exact opposite of the first rule. It says that if a light ray passes through the focus, or it is thrown at the mirror after passing through the focus, it will reflect back parallel to the principal axis. Okay. Similarly for convex mirror here, if it is thrown, it appears to go towards the focus, right? It's like this. If it appears to go towards the focus, it will be reflected parallel to the principal axis. So like this, like this, like this, like this. Understood? It is the exact. Oh, I'm sorry. This is wrong. Ulta kar diya maine. Yeah, sorry. So if it is like this, it goes like this. Understood? So this is the second rule. If the light ray passes through the focus, it will be reflected back parallel to the principal axis. Now the third one. The third one says that if a ray passes through the center of curvature, if the ray passes through the center of curvature like this, it will trace its path back. Okay, so that means if it goes like this, it will come the same way. It will come back the same way. It will not deflect at all. Okay. The reason for this is that on this mirror, if you form on this small piece of mirror, it almost acts as a straight line, a plane mirror, a straight line of the mirror, right? And if you draw normal there, it will be along this line itself. Okay, so that is the reason why it reflects, or it traces its own path. Understood? Okay. Similarly it's the same thing for the convex mirror. Okay, so if you direct it towards the center of curvature, it will trace its path back. Okay, simple enough. So this is the fourth rule. It is the third rule. Now moving on to the last and the fourth rule, which says it is the second law of reflection. This is basically nothing but the second law of reflection. It follows for the pole. So if a light ray is directed towards the pole, right? So here this is 14 degree. So downwards also I'll go 14 degree here. Okay, like this. It will reflect back like this. Understood? So angle of incidence is equal to the angle of reflection. This is the fourth property. Similarly it's the same thing for convex mirror. So if I go 35 here, 35, it will similarly 35 in the downward direction. Okay, so this is the fourth rule of the ray diagrams. Angle of incidence is equal to angle of reflection. Simple. Okay, understood? So these, you have to keep in mind these four rules. Now, when we move on to the image formation by the spherical mirrors. So using these rules only will make the ray diagrams, and will understand how different images are formed based on the position of the object. Okay. So now we'll move on to image formation by firstly concave mirror. Concave, you remember, concave mirror is curved inwards, right? So this is a concave mirror. Now understand, I have made the ray diagrams beforehand because it will waste a lot of time in making them now, right? So I made them beforehand. I'll explain it to you. Hope you'll understand it. Okay. So see what happens. The first case, there are total 6 cases for concave mirror and 2 for convex mirror. So the first case for concave mirror is that the object is kept at infinity. So it is at infinite distance from the mirror. That is the meaning. Okay, so we can't show it on the principal axis, right? It is at infinite position. So how can we show it? So we show it by a dotted line here. We show it by a dotted line here, as you can see, right? So that is the object. Okay, so here if a ray is drawn, it goes parallel, right? So it will pass through the focus. Similarly, if a ray is drawn from the infinite object, so the ray, you have to understand, the rays coming from infinity are always parallel to the principal axis. This is a axiom, you can say. It is universally accepted. Okay, so the rays which come from infinity, they are parallel to the principal axis. You have to understand this. Okay, so when they are parallel to the principal axis, they will obviously reflect back through the focus. So both the rays, they reflect back at the focus. Okay, am I right? Okay, so now we'll see. So you know now that the position of the object, the position of the object is at infinity, and the position of the image will be at the focus. So this tiny focus point is the image. You have to understand. So such a large object, because the object is at infinity, right? So such a large object, it forms such a tiny image at the focus. So the size is highly diminished. Okay, the size is highly diminished. It is highly reduced. Diminished is a better word, so use diminished. Highly diminished. Point sized. Okay, size, you can write point size. It is a point sized image. And the nature we guess the nature is real and inverted. Okay, the nature is real and inverted. Understood? The first case done. Okay. Okay, now let's move on to the second case. The second case is the object. Now we are moving the object closer and closer to the mirror. So the second case is that the object is between infinity and C, or we can say the object is beyond C. So it is visible to us. The size of the object is visible. You can see it. At infinity, we cannot see it, right? Okay, so the rays coming from there are parallel. But here, not necessary. The rays are not necessarily parallel. So here we have an object O here, as you can see, this. Now we direct a ray parallel to the principal axis. It passes through the focus, right? Now, if we direct a ray through the focus, it will pass parallel to the principal axis. The first two rules of ray diagrams. Okay, So where these two lines, the reflected lines, this and this, they intersect this point, there the image will be formed. So I've drawn the image by using red color, as you can see. Right? So this is the image. Okay? So now what is the position of the image? The position is, it is between C and F. Oh, I'm sorry. Between C and F. Okay, what is the size of the image? As you can see, this is larger and this has been diminished. So it is not highly diminished, it is not point sized, right? Here it is just diminished. Okay, it is diminished or reduced. The size is reduced or diminished. And the nature, you can see the object has been inverted. So the image is inverted. So it is real, basically the rays are actually meeting, right? So it is a real image and it is inverted. Okay, simple enough to understand? Okay, now we'll move on to the third case. The third case is that the object is at C. Now we are moving it closer and it is at C. So what happens? Here again, the same two rays we are directing. First, parallel to the principal axis, passes through the focus. Second, passing through the focus, parallel to the principal axis. And it forms an image which is again at the center of curvature itself. So the image is at the center of curvature itself again. So this is a special case, I'll say. Okay, it is a very, very special case because the image is also formed at the center of curvature. So here we'll write the position at C. The position will be at C. The size will be exactly the same. So no difference. Same size. As you can see, the size is same, right? There is no difference in the size. Okay. And the nature, again you can say it is real and inverted. Real and inverted. Okay. Now, you understood this one? Now we'll move on to the fourth case. The fourth case is object between C and F. The object is between C and F. So we are moving it again closer to the mirror. Okay, now the first ray we direct towards parallel, it goes through the focus. Through the focus, parallel to the principal axis, right? And it meets the reflected rays, they meet at this point, and this is the image formed. Okay, so here the position is beyond the C. Can you see that? Sorry, the position is beyond the C, right? So it is after C, it is between C and infinity. Okay, you can write that as well. And the size, it is enlarged, it is slightly enlarged, not much, it is just enlarged, okay, or magnified, whichever you want to write. Enlarged or magnified, right? And the nature, again, it is real and inverted. The nature is not changing. Okay. So it is real. So are you seeing this one pattern? Like it's not a pattern, I'll say, but when it was beyond the C, the image formed between C and F. And when it is between C and F, the object, the image is forming beyond the C. So you can remember it like it's opposite, right? So you can remember it that way. Okay. Now we'll move on to the fifth, which is the object is at F. I'm moving it more closer. The object is kept at the focus. Now what happens? Again, same thing. Now the second ray we have drawn is different. The first ray is parallel, it goes through the focus. Okay? The second ray, it is directed towards the pole, so incident angle and reflected angle equal, and it will pass like this. So now if you notice in this case, the two reflected rays, they are parallel to each other. Now what is the meaning of parallel? It means that they will never meet. It means that they will never meet. So we assume, okay, or it is said in scientific terms that the image, it will be formed at infinity. The image, it will be formed at infinity. So we'll write the position at infinity. because it is never going to form, right? The rays, even if they are traced back, even if these rays, if we trace them back, they will never meet because they are parallel, right? So hence we assume that the rays, or they will meet at infinity. Okay, the rays will meet at infinity. Fine. Now the size of the image, it will be highly enlarged. The size will be highly enlarged at infinity, right? Highly enlarged. And the image, I'm sorry, I should have written nature. I don't know why I've written image. Yeah, the nature. The nature, it will be real and inverted. So no change in the nature. So again, you can see, reversal. The first one was that when the object was at infinity, the image was forming at the focus. Now here, when the object is at the focus, the image is forming at infinity. So you can remember it in this way, right? Okay. Now, the sixth, last case. This is an interesting case. This is very interesting. Okay. Until now, all the images were real and they were inverted. Now, in this case, let's see what happens. Okay. So, again, now this time, I forgot the object. This time, the object is kept between the focus and the pole. So, it is very, very close to the mirror. It is between the focus and the pole. Okay. So, again, parallel through the focus and towards the pole, angle of incidence is equal to angle of reflection. Now here, the two reflected rays, they are diverging. That means when they continue, they will never meet. But if they are traced back, they are meeting, right? So we will trace them back. For parallel rays, even if we trace them back, they will never meet. Okay, so after tracing them back, what we get is we get the image, but we get it behind the mirror, right? So the image is formed behind the mirror. So what does that mean? It is virtual. So the nature of the image is virtual, okay? And it is erect. Obviously, it is not inverted, right? So that means it is erect. So the nature is virtual and erect. The position is behind the mirror, right? Behind the mirror, and the size is enlarged. It is a bit enlarged, not too like highly enlarged, but it is enlarged or magnified, right? Okay, so in this way we have completed the 6 cases of concave mirror. Okay, so now we'll move on to the uses of concave mirrors. So what are concave mirrors used for? So the first thing that they are used for, it is they are used as shaving mirrors, or makeup, or dentist mirrors as well. Okay, the all three, they work on the same principle. Okay, so these all three work on the principle of concave mirrors. So what happens basically, for example, let us take dentist mirrors. Okay, so the dentist mirrors, they are like very small, right? And they hold them very close to the teeth. The dentist, he holds them very close to the teeth, and he can see an enlarged image in the mirror, right? So he can see the cavities and whatnot. Okay, so what happens? The sixth case happens. This case happens, that when you hold it very close to the tooth, right? When you hold it very close to the tooth, what happens is you will get an enlarged image, right? It becomes a virtual image, right? So it is used for shaving, makeup, or dentist mirrors. Okay, the second is it is used as torchlights. Torchlights or the headlights of cars. Torchlights or headlights of cars. Okay, how? See, the bulb of the torchlight, it is placed at the focus. Now, from the focus, when it is thrown at the mirror, these surfaces, the sides of the torchlight, right? They are like a metallic silver color. So these are concave surfaces, concave reflecting surfaces. So when the light from the focus, it is directed towards the sides, it goes parallelly, right? It goes parallelly. So from the focus, it goes parallelly, right? We have seen the second rule of ray diagrams. So hence a powerful parallel beam of light is produced. and hence it helps in the intensity of light and everything. So hence a powerful beam is produced, and hence it is a concave mirror is used in the torch lights or the headlights of cars. Okay, and the last use is in solar furnaces or solar cookers So this works on the first ray diagram, where the rays were coming parallel. So from the sun, as the sun is considered to be an infinite distance, from the sun parallel rays of light will come. Now these rays, when they meet the concave mirror, right? And when they meet the concave mirror converges them at a single point. So if these are the rays coming, the concave mirror will converge them at a single point, and at that point the solar furnace is kept, or the solar cooker is kept, right? And hence the cooker or the furnace, it starts to heat up, and solar energy is basically produced in an enormous amount. Hence it is very efficient. So concave mirrors are used in these three purposes. Now we'll see convex mirrors, the image formation by convex mirrors, and uses in the next part. So that's it for now. Thank you so much.